Wonderful day everyone. Today I'm going to discuss about evidences of plate movement. The Earth is estimated to be 4.54 billion years old, plus or minus about 50 million years. It is essential to know what happened to our planet based on what it is before compared to now. What do I mean by that? Let's begin. The world we usually see right now is in very different condition millions of years ago. It is amazing when we think about how this planet transformed to the Earth that we knew and love. 335 million years ago, there is one huge landmass surrounded by water with different species of living things that might be extinct as of this moment. Did you hear about the continental drift theory? It describes one of the earliest ways geologists thought continents moved over time. In the early 20th century, Wedgner published a paper explaining his theory that the continental land masses were drifting across the Earth, sometimes blowing oceans into each other. This land mass is known today as Pangaea, a supercontinent that existed during the Paleozoic and Mesozoic period. If think about it deeply, this is a big transformation of moving big land masses into different parts actually dictated how life in this planet will function in every unit. The supercontinent Pangaea is a part of the continental drift theory, a theory supporting plate movement. These supercontinents started to move away from each other to create the 7 continents of the world that we are seeing right now. The 7 continents are Africa, Antarctica, Asia, Australia, Europe, North America, and South America. The force that causes most of the plate movement is thermal convection, where heat from the Earth's interior causes currents of hot rising magma and colder sinking magma to flow, moving the plates of the crust along with them. In a ridge push slab pull, gravity is acting on the plate to cause the movement, and also scientists believe that one of the primary forces behind the plate movement is thermal convection. Alfred Lothar Wegener, 1880 to 1930, who was a German polar researcher, geophysicist, and meteorologist. He is remembered as the originator of the continental drift theory by hypothesizing in 1912 that the continents are slowly drifting around the Earth, and it is once a large landmass called Pangaea, a Greek word that means all Earth. Continental drift theory would be the foundation, a very important theory that is supporting plate movement and especially the plate tectonic theory. His theory was rejected because of its lack of evidence. Wegener, which is the center of the idea, can't explain the unknown force or reason behind this big landmass to move and create space away from each other. They accepted the theory when they discovered the reasonable force for this tectonic plate to move. For his theory to succeed, he provided us 5 pieces of evidence that will prove that continental drift theory is actually happened and accurate. The first evidence is mainly about geological fit. Evidence is the matching of large-scale geological features on different continents. It has been noted that the coastlines of South America and West Africa seem to match up like a jigsaw puzzle. However, more particularly, the rock terrains are separate continents confirm as well.
Fossil evidence is the second piece of evidence in Wegener's theory. Alfred Wegener emphasized evidence regarding the fossils of ancient animals and plants, specifically on how they ended up in completely different areas from their supposed habitat and origin, sometimes on a different continent altogether. The main purpose of this evidence is to prove that the 7 continents of the Earth came from one huge landmass, and these species cannot just travel from one area to another. It means that these species are once lived together before the movement of landmass began.
Glaciers carve rocks and leave marks as they move. In this evidence, scientists can determine the direction of movement of each continent. The marks indicated that the continents did in fact move and could even be used to determine their direction. The fossil evidence found in these regions is quite similar to the second piece of evidence. This proved that although the continent was too cold to be inhabitable by most animals currently. The fourth evidence discovered that the rock terrain and rocky type was similar in most mountain ranges across continents, seemingly matches and connecting even though they were found in different continents. The last piece of evidence is coal deposits. Most of these swamps existed only in specific areas, so coal deposits in areas that could not support swamps would not make sense unless climate change and plate movement was involved. Dead plants from swamps would often fall into swamps. New dead plants would fall above it, causing compression and in turn cause heat and pressure, thus producing coal. Seafloor spreading. Theory that oceanic crust forms along submarine mountain zones, known collectively as the mid-ocean ridge system, and spread out laterally away from them. This idea played a pivotal role in the development of the theory of plate tectonics, which revolutionized geologic thought during the last quarter of the 20th century. The seafloor spreading hypothesis was proposed by the American geophysicist Harry H. Hess in 1960. On the basis of the TARP's efforts and other new discoveries about the deep ocean floor, Hess postulated the molten material from Earth's mantle continuously wells up along the crests of the mid-ocean ridges that wind of nearly 80,000 kilometers or 50 miles through all the world's oceans. As the magma cools, it is pushed away from the flanks of the ridges. The spreading creates a successively younger ocean floor, and the flow of the material is thought to bring about the migration or drifting apart of the continents. 1980, one of the key pieces of evidence supporting plate tectonic theory was the discovery that rocks on the seafloor record ancient reversals of the Earth's magnetic field. As the rocks are formed where plates are moving away from one another, they record the current direction of the Earth's magnetic field, which flip-flops irregularly over very long period of time. In this flip-flops, the polarity of magnetic field changes, so that a compass needle might point south for 200,000 years, and then point north for the next 600,000 years. As evidence, the new seafloor would magnetize in the current direction of the magnetic field. The seafloor produced from ocean ridges would produce magnetic stripes parallel to the ridges. Preserved magnetic materials were found inside old volcanoes. They were reversed, meaning that geomagnetic reversal indeed happened in the past. I hope you learned something. Thank you for watching.